So we've seen already, and I've hinted at this definition. I think I've actually stated it outright, but I want to just be very clear about this. So two propositions, say P and Q, so two propositions are equivalent if, so say P and Q, let's actually give these names. So two propositions P and Q are equivalent if they have the same truth values. So if they have this, if they, in other words, determine the same truth tables, they have the same truth values. And if these are equivalent, we write that P is equivalent to Q with a 3, so it's kind of like an equal sign with an extra line. This is, when I say equivalent, that should, I think, hopefully trigger a memory of stuff that we've already talked about. This is, it turns out, an equivalence relation. So this type of equivalence is an equivalence relation in the sense of equivalence relations that we talked about before. This is an equivalence relation on the set of all logical propositions. So it turns out that this is a equivalence relation. And then, so we've also seen one example. So we've seen that P implies Q is equivalent to its contrapositive, not Q implies not P. Okay, so this is the what I'm going to call the law of contraposition. And then there's one other place where something familiar is going to just pop up here. It turns out that if we negate an or statement, think about what it means for P or Q to be false. That means that P is false and Q is false. And likewise, if you want to negate P and Q, in order for P and Q to be false, either P is false or Q is false. And these, of course, are, let me make this a little easier to look at here. This, of course, is the logical version of De Morgan's law. So De Morgan's law had a counterpart when we were talking about set complements, but this is the logical complement. So this is also going to be categorized as De Morgan's law. All right, so that's everything I wanted to say about equivalences. Just two more definitions, and then we'll be done with this. We'll be done with this section of talking about logic. A tautology is a proposition which is always true. Okay, so it's a proposition which is always true. So this is something, think about, say, P or not P. Okay, so no matter what the truth value is of P, P or not P will always be true. A contradiction is a proposition which is always false. And I'm just gonna, little iPad cheating here. Hopefully I didn't get anything that I don't want. There you go. So it's a proposition which is always false. And a good example, I think, would be P and not P. So again, no matter what the truth value is for P, that's always going to be false. Okay, so that's a tautology, and that's also a contradiction. So that's what we mean when we talk about a logical contradiction.